क्या चाहिए बताओ क्वेश्चन में चाहिए लास्ट ब्लूप्रिंट भेजूंगी कैसे आने वाला है लेकिन ये 3 साल एसएसटी का देखते हैं एसएसटी का मैच कर रहे हैं एक दिन मेरा मुझे समझ में आया मेरा क्या लिखा है मैं तो पढ़ती नहीं वो तो बस ये नहीं पढ़ती हूँ दूसरा क्या होगा मैंने जान बुझ के नहीं पढ़ा नहीं केमिस्ट्री
So I'll share this.
अच्छा रिविजन
Where did we stop in the last class? Example 9.1 हो गया था कि हो गया 9.1 completed sign convention होगा start with example 9.2 Let's write down the given data. Okay. So can I have everybody's attention on the board?
कौन सा क्वेश्चन
So what is given here? So you have to write down the given data with appropriate sign wherever applicable. Okay. So object size given is 4 centimeters.
The sign will also right.
Yes, it is right. It is 4 centimeters. So if it is positive, you can write it as it is. Place that 25 centimeter in front of concave mirror. So it is given concave mirror. Yes. So U is always
Negative.
negative. So U is minus 25 centimeter. Focal length is 15 centimeter and it has to be minus. So focal length for concave mirror is negative. At what distance from the mirror should the screen be placed in order to obtain a sharp image? That means you have to find the image position V. So V is equal to what? So screen has to be kept at V. Find the nature and size of image. Nature of image and size of image, that is H dash. Size of image is H dash. Okay. So let us solve. So since 1 by F is equal to what is 1 by V? 1 by F minus 1 by U. So this minus 25. So you can write 1 by 25 minus 1 by 15. So LCM of 25 and 15 would be
75.
75. This means 3 minus 5. So which means minus 2 by 75. Therefore, V is equal to minus 75 by 2, which is minus 2V minus 37.5 centimeters. So V is negative, right? Which we got. To find the nature, what do? We find magnification, right? So ये answer क्या हो गया? Therefore, screen has to be kept. Screen must be kept 35 centimeter at 37.5 centimeter in front of mirror. What is the answer? Screen has to be kept at 37.5 centimeter in front of it. Be negative. Further, नेचर निकालने के लिए हमको क्या फाइंड करना पड़ता है? मैग्निफिकेशन. M is equal to minus V by U. So minus 37.5 or minus 25. ये फिर से माइनस ही आएगा ठीक है तो ये कितना होगा 5 से कट करो 5 7 का 35 ये कितना हो गया 2.5 so m is equal to minus 2.5 1.5 yes minus 1.5 ठीक है 535 505 correct so m you are getting is minus 1.5 right so for so m is h dash upon h is equal to minus 1.5 therefore h dash is equal to minus 1.5 into h which is minus 1.5 into 4
minus 6.
this is minus 6 centimeter
Yes.
so h dash is 6 centimeter inverted because it is below the principal axis so it is real and inverted okay so everything therefore image is real and यहीं से मालूम पड़ेगा magnification negative is real and
Inverted. More than one enlarged image. Enlarged image.
and enlarged ठीक है and this gives the size of image ये भी आंसर हो गया this is answer so we can do anything we'll take in-text question from NCERT image problem okay so with this we have completed the examples of both but there are certain in-text questions let's do that there are in-text question in NCERT every desk has an NCERT book
Yes, sir.
so I'll just dictate the question right down the first question is very easy write the question find the focal length of a convex mirror those who have the book can solve the question correctly those who don't what's the page number 145 the new book page 145 in-text question so what is given is you have a convex mirror whose radius of curvature given is 32 centimeters. You have to find what is the focal length. Plus or minus? Plus. So given convex mirror, and R is equal to 32 centimeter. It has to be plus only. Therefore, F is equal to R by 2. 16 centimeters. This is the answer. Now write down the next question. A concave mirror produces, this is question 2. A concave mirror produces, write down, those who don't have NCERT book. A concave mirror produces 3 times magnified, 3 times magnified, bracket में enlarged real image of an object placed at 10 centimeter in front of it.
Minus 10 and minus 10.
Of an object placed at 10 centimeter in front of it. Full stop.
Minus 8.
Where is the image located? Where is the image located?
Minus 30 cents.
Minus 30 is correct. Everybody got it?
Yes, sir.
Very good. Anybody needs help, please ask. So if you have understood the concept, okay, all questions will be child's play, right? So let me do it for you. Question 2. क्या था? First of all, it is a concave mirror. Produces 3 times magnified enlarged image. मतलब m is equal to minus 3. This is given to you. An object is placed 10 centimeter in front of it. This is also given. Where is the image located? You have to find V. So you know the relation between M, U and V?
Yes.
Sir, magnification negative.
Real है ना? क्योंकि image is real.
Negative.
Real image दिया ना? Given में. Question में दिया है real image. तो real के लिए magnification करना पड़ेगा. Question में real image mentioned है. तो क्या होगा? -3. Negative for real image. Okay. So solution. So M is equal to V by U. Therefore, V is equal to minus MU. What is X? -3. U is -10. So minus minus, this becomes -33. Okay. So you got to be careful. Every information, given information, you must write down. So M, in case of concave mirror, M can be 3 as well as -3, depending upon if the image is virtual or real. Okay. The nature of image will tell you the sign. Okay. So with this, we have completed the mirror part of this chapter. Okay, reflection by spherical mirrors is completed. Now we'll start with refraction of light. Okay, let's start with refraction. Can I erase this? So I think you have studied about refraction of light in your lower grades, right? Have you studied about refraction of light? So what's the definition? What is refraction of light? The direction of light, what about the direction? Changes, right? So whenever the light passes or travels from one transparent medium to the other transparent medium, the direction of its path changes into second medium. Okay, so this phenomenon is called refraction of light. Okay, so I'll just put the diagram. AB is the boundary separating two transparent mediums, right? What are the transparent medium you are familiar with?
Glass slab.
Air,
Glass
glass, water. These three are very common. Right now we are dealing with two mediums, air and this glass. So refraction, this is practical example. And when some deep sea diver or swimmer with a specs enter into the pool of water, then he is facing all the three mediums. Above the water level, air, water level, and glass. So this is very, very common and practical thing that we deal with on a daily basis. So there are certain observations in nature because of refraction of light that you have to understand. So AB is the boundary separating two mediums. So what is the first medium?
Air.
Medium one is air. Sorry. Okay, and medium two is
Water.
anything, any denser medium. So this is rarer medium. This is rarer medium. And medium two is, let's say, glass. So it is a denser medium. So when the light ray travels obliquely, so this is the point of who is chatting. Pay attention here. So when the light is incident on the boundary obliquely, so this is the point of incidence O. Let us draw the normal. So whether it is reflection or refraction, normal has a key role to play. So NON dash is normal at point of incidence. Now, this angle is called angle of incidence. So what was the original direction? This was the original direction. Now it is observed that the path of light in the denser medium bends towards normal. So in the denser medium, the path is bending towards normal. And this angle is now called angle of refraction. Okay. So I is angle of incidence. R is angle of refraction. Right? And we will define one more angle. Let's call this angle as delta. So this delta is angle of deviation. Okay, so you can see that the path of light is not in the original direction, but in the second medium, the path has changed. This phenomenon is called refraction of light. Okay. So the phenomena of bending of light when it in the second medium one transparent medium. The other transparent medium is called refraction of light. Okay, so this bending itself is called refraction of light. Now, what's the reason for it?
Change in optical units.
Yes. So what happens because of that?
Speed of light.
Yeah. So you know that light travels fastest in air or vacuum or air. In all other medium, its speed decreases, right? So it is traveling very fast till it hits the point of incidence, then it slows down. So when it slows down, its path changes. Path changes due to change of speed of light in different mediums, right? The reason for change of direction of path of light in the second medium is due to difference in the speed of light in different mediums. Okay. So path bends towards normal. Bends towards normal when light enters from rarer to denser medium. Whenever light travels from rarer to denser medium, it bends towards normal, and vice versa. And vice versa. Which means if the light travels from denser to rarer, so here it is traveling at a lower speed, but suddenly the speed increases. So it goes away from normal. Okay? So this is the funda of refraction of light.
Sir, is the angle of deviation always denoted by delta?
I have seen that only, but you can denote by other thing also. But standard notation is delta. Angle of deviation is delta. Why? Any problem because of that?
No.
Okay.
Then book is not.
आएगा ना अभी तो आगे आएगा. This is extra if it is not given. Okay. So what is this angle of deviation equal to?
Angle of frequency.
In the diagram, geometrically, how much it will be?
X minus.
Yes, I minus R. Because vertically opposite angle I is equal to R plus delta. This is vertically opposite, right? I equal to R plus delta. So delta is I minus R. There. Now, is I equal to R in this case? Like laws of reflection?
No, sir.
So it is different. So refraction of light obeys different laws. Okay, let me now define the laws of refraction, which is given little later. Shall I do the same thing as it is given in the book? So then you have a different topic, studying refraction of light by a rectangular glass slab. So we do that first and then we cover the laws of refraction. Okay. Is this written? Can I erase the left part? Okay. This is part of your practical. Okay. They might ask you to do in the school, right? So you will require a rectangular glass slab. A cuboid shaped glass slab will be provided to you, right? So then what you have to do is take a chart paper, right? So on the experiment table, so which is horizontal, take a chart paper, paste it or pin it on the drawing board. Then keep the rectangular glass slab like this. Okay, have you done this experiment?
Yeah.
Okay. Then what you have to do is, so let us say this is how we are doing the experiment. So there are two sides. Okay. The glass slab, you are on the side of the glass slab and the side behind it. Right. So then what you will do is you will stick pins. Okay. Let us say you inserted a pin here and a pin there. Okay. Two pins are inserted like this, obliquely. So that when you draw the line, both the pins are actually on that line. And you have to run the pencil at the base of the glass slab. So on the chart paper, you will have the position of the glass slab and you also have the position of the pin. Right? Now what you have to do is you have to look at the pins from the other side, not from above, through the glass slab. Okay? What you have to do is you have to look through the pins through the glass slab. So when you change the angle, reading angle, both the pins will be in one line. Okay, so let us say you have pin 1, pin 2. You should only align yourself in such a way that you are able to see only pin 1 and pin 2 is behind pin 1. Got it? So that will ensure that both the pins are in the same line. Got it? And then while you are looking at pin 1, you insert the pin on your side. So that now you only see the pin that you have inserted. So that everything is in one line, appearing to be in one line. Okay? And again, insert one more pin on your side. So pin 3 and pin P4. So 4 pins are inserted. And when you are looking, you are only able to see the 4th pin. All other pins are behind it. So which means all of them are in the same line. So once you have done that, right? You have 2 pins on your side. Now you draw the line because you need 2 dots to draw a straight line. Okay. So when you do the experiment, let us say this is the base of the rectangular slab. So this is what you are going to find. Let us say the 2 pins were here. Let's say this is pin 1 and this is pin 2. Right? This is what you have done. Now, when you're looking through it, while looking on the other side, what is it? What is the original direction? This is the original direction, okay? But when you're looking from the other side, what you find is you end up inserting the pin at these locations. And now when you draw the line, this is where you get your pins. Okay, so you have two straight lines and then you join these lines. Okay, so what do you find? Now you draw the normal. Then you draw the normal here also. Okay, so what do you find? The light ray bends in the glass slab. Now this is the experimental finding, right? And is there any deviation in the final output ray? Is there any deviation? No, there is. This is parallel ray. So all the bending, whatever bending happened inside the glass slab, the reverse bending happened when it came out. Because what is the medium here? This is air. This is glass. This is air again. So the bending of light, whatever bending happened here, okay, that bending is reversed when it came out. So there is no deviation between the final output. This is called emergent ray. This is called emergent ray. This is called incident ray. Okay, so this is angle of incidence, I. What is the angle given in the book? E R2, I1, R1. This is I1, this is R1. Then this is given as I2 and this is R3. And this is R2. This piece. So what you observe is in the emergent ray you have lateral shift. I'm calling it XY. So XY is the lateral shift. What is the observation? There is no deviation. The between the incident ray and emergent ray. Except the lateral shift. This is the observation. Yes, this is the observation. And it is because of symmetry. The medium, the pair of mediums, right, are air and glass for one kind of refraction, and then again you have glass here. So whatever bending happens here at the first interface, let's name it yeah, no, ABCD. Okay, so whatever refraction of light takes place at boundary AB, the opposite happens at boundary DC. Okay, so that's why these rays, incident and emergent rays, are parallel to each other. Right? Can it be geometrically proven? Can it be geometrically proven? So let us say this is N1, this is O, this is N1 dash, this is O dash, this you can take N2, N2 dash. So this is rectangular glass slab, so AB is parallel to DC, right? So geometrically, geometrically, AB is parallel to DC. Rectangle. Opposite sides of rectangle are property of rectangle, right? It's a rectangular glass slab, right? Since rectangle. So opposite sides of rectangle are parallel. Then N1 O N1 dash must be parallel to N2 O dash N2 dash. Correct? Normals on two parallel faces will be parallel to each other. Correct? Normals on parallel faces. These are normals on parallel faces. It has to be parallel. Now, so therefore, this implies angle R1 must be equal to angle R2. Correct? Angle R1 is equal to angle R2.
Sir, that R2 is emergent angle of emergence.
Yes, here it is. Oh, I2, not R2, I2. This is R1, this is I2. Correct? R1 has to be equal to I2 numerically. Alternate angles. What is it? Alternate angles. Right? So this corresponds to angle I1 must be equal to angle R2. Isn't it? If R1 is equal to R2, then I1 has to be equal to R2.
Alternate exterior.
Why?
Alternate exterior.
Huh?
Alternate exterior.
Not alternative exterior. This is where properties of refraction. Refraction taking along same pair of medium. Isn't it? So if for I1, if the angle of refraction is R1 and R1 is equal to I2, then this must be same to this.
So that can also be.
That can what?
That can also be connected to
What was the set?
alternate exterior angle.
Sir,
Alternative
that-
exterior angle.
that this normal and that normal is parallel to each other. Hence, angle R and angle R1 and angle I2 are equal, and angle I1 and angle R2 are equal.
So I'm not aware of that property. Do you have any property like that? What is it?
Alternate exterior angle.
Alternative exterior or corresponding angle. Are you talking?
Very different.
Corresponding is different. The transversal is same. Is it the property of parallel line? I'm not aware.
Yes, sir.
Okay. But then here, by refraction also, it is refraction taking place at the same pair of medium. Okay? So this, if these two are equal,
So that is also.
then these two also have to be same because refraction is taking place across same pair of mediums. Since refraction. But this I am giving extra. This is not required. Only you have to draw the diagram and write the conclusion. This is just for geometry's sake. Since refraction is taking place across same pair of medium. Okay. There is actually one more concept, path of reversibility of light. Meaning, if light was coming in this direction, and if you reflect it back, let's say you place a mirror and the light is incident normal to the mirror, then this path will be retraced as it is. Okay, so this is symmetry. So by symmetry also I1 has to be equal to R2. So R2 is called angle of emergence. That is, in case of refraction of light by rectangular glass slab angle of incidence or angle of emergence angle R2 in our diagram is equal to angle of incidence. So these are the two results that you have to write. Right? Even if you don't give those steps, these two observations have to be mentioned. Okay, and the diagram has to be drawn. So you have to mention the lateral shift and angle of emergence is equal to angle of incidence. These two things should be highlighted along with the diagram. Is it clear? If the diagram is not clear, you can see it in the book. Right?
In a plane mirror, is the ray of light coinciding with the normal? In a plane mirror, is the ray of light coinciding? In a plane mirror, when the ray of light is falling on
Only when it is falling along the normal. Coinciding with the normal only when it is incident along the normal. Otherwise, it will make an angle with the normal. The reflection will take place. So if your question is, let us say this is the plane mirror, okay? How the ray is incident? Is it incident obliquely? Or if this is the normal, how is it incident along the normal? How it is incident, it will depend on that. Is that the question?
I was having a question. I saw a question once that when a ray of light is falling on a lens, some concave or convex spherical mirror, along with the normal. So what will be the angle of refraction?
Angle of refraction.
Sir, in a plane mirror, different the angle of reflection is falling on and the angle of the incident rays falling normally on the plane mirror. So what will be the angle of reflection?
Reflection. Zero.
Refraction.
Refraction. प्लेन मिरर में कहाँ रिफ्रैक्शन होगा?
Question plane mirror आता है.
रिफ्रैक्शन होता ही दो मीडियम में है. प्लेन मिरर में मीडियम कहाँ चेंज होता है?
So it will be zero. It will be zero.
Yes. अब तुम्हारा मिरर अगर थिक है, ठीक है, मिरर थिक हो गया, तो कुछ पॉसिबिलिटी है. Let us say it is a thick mirror, right? So now you have got two mediums. तो यहाँ पे तुम्हारा अगर नॉर्मल की तरफ आ रहा है तो सीधे जाएगा, ठीक है, और रिफ्लेक्ट होकर इसी लाइन से वापस जाएगा. अगर तुम्हारा यहाँ पे गया है इधर से लाइट एक ऑब्जेक्ट में, तो क्या होगा? अब यहाँ पे रिफ्रैक्शन हो जाएगा, डेंसर मीडियम, ठीक है. तो यहाँ पे पार्शियल रिफ्लेक्शन भी होगा और ये यहाँ से फिर से अब यहाँ पे रिफ्लेक्ट होगा और फिर यहाँ से वापस रिफ्लेक्ट होगा. एनीबडी, एक तो ये लाइट जा रही है ऐसे, तो इसका जो इमेज बनेगा वो यहाँ पे बनेगा, यहाँ के.
Then what if it is a glass slab?
ग्लास स्लैब का तो बताया ना तुमको.
Parallel to the coinciding with the normal. In glass.
Then no deviation, सीधे चला जाएगा. Nothing. If it is coinciding like this, कुछ नहीं होगा. There will be no deviation. ऐसे जाएगा. So normal is an exception for both reflection and refraction. What's the question for rectangular transparent glass slab or for a mirror?
Glass.
Now it is correct. If the ray is incident, okay, listen everybody. The question is, it was not mirror, it was a glass slab. So if the ray is incident along the normal glass slab, so will it deviate? No, it won't deviate. That was the question. No, mirror means a glass slab.
Mirror पे पूछना है. Glass slab का पूछते तो आप लोग.
नहीं, कंफ्यूजन हो गया उसको. मिरर में भी है, आईसीएसई में ऐसा भी है. मिरर के अंदर भी, if the mirror is thick, so it has got two surfaces. But if the mirror is thin, refraction is ignored. अपन घर में thick mirror थोड़ी ना लगा, thin लगाते हैं. So for viewing mirror is always thin mirror. Mirror में भी है refraction, not only for thick mirror. Okay? And if the question was this, along the normal, तो सीधे निकल जाए.
Thick mirror it will deviate for some angle.
Depends यार, मतलब follow the ray diagram, right? Apply the laws of reflection. होता क्या है? Every plane surface will partially reflect. तो यहाँ से भी light reflect होगी थोड़ी सी, 4%. But maximum light will get transmitted. But यहाँ से 100% it has to be reflected because here you have silver coating. यहाँ से आगे नहीं जा सकते. तो अंदर में तो यहाँ पे क्या हो रहा है? रिफ्लेक्ट हो रहा है यहाँ से. यहाँ पे लाइट रिफ्लेक्ट हो रही है अंदर, लेकिन बाहर फिर क्या होगा? रिफ्रैक्ट हो जाएगा. समझ आ रहा है? तो अगर कोई यहाँ से देखेगा तो अभी उसको क्या लग रहा है? ये लाइट कहाँ से आ रही है? एक तो यहाँ से आ रही है, एक तो यहाँ. तो ये विल सी द इमेज ओवर हियर. इसका ऑब्जेक्ट का इमेज यहाँ दिखेगा. इमेज जैसे मिरर में दिखता है वैसे ही दिखेगा. बट नाउ यू कैन सी मल्टीपल इमेजेस, क्योंकि यहाँ से फिर से तो नीचे आएगा. Infinite images will be formed. समझ आए? Infinite images. इन मिरर में एक दिखेगा, ठीक है. और वो इनफाइनाइट में से जो सेकंड इमेज है वो ब्राइटेस्ट होगा, बाकी सब फेंट होगा. तो आईसीएसई में एक टॉपिक है 10th आईसीएसई, ठीक है. So any questions on rectangular glass slab? Okay. Now we have laws of refraction. So we'll just state the laws and I'll explain in the next class. So do you have time? 5 minutes में हो जाएगा. Law लिखना पड़ेगा. So what are the laws? The laws of refraction are, one law is common. So this is our diagram for laws of refraction. First law is similar to laws of reflection. The incident ray AOB, ये हो गया PQ. So the incident ray, the refracted ray, and the normal at the point of incidence lie in the
Same.
same plane. Okay, this is same as law of reflection. IR is incident ray, RR in this case is refracted ray, not reflected ray. Okay. Second part of the law is another law. Second part of the law is another law, which is called as Snell's law. What does it say?
The ratio of this sine of factor difference to the sine of the angle of refraction is always a constant for a given pair of medium.
Correct. Is equal to constant for a given pair of medium, and a wavelength means color. What does the wavelength signify? The color of light. If the color changes, the wavelength will change. So imagine this is a monochromatic incident ray. It's a monochromatic.
Then what is this?
Single color ray. This relationship is applicable for a monochromatic ray of a single color or single wavelength. Okay. And this constant has got a specific name. It is called refractive index of the second medium with respect to first medium. It is written as 2:1 or N2:1. For a pair of medium and given wavelength of light. Okay. So if you take a light of red color, the deviation will be different. If you take green color, the deviation will be different. Got it? When same pair, air and glass. So this is air and glass. Change the color of light for the same pair of medium. The bending will change. Okay, we'll explain in the next
Thank you.